Okay, we're going to look at inverse operations, and they're really important in mathematics and lots of different places. So, anyways, if you have this, we know that 7 plus 11 is 18. Okay, now how would I undo that operation so that I get back to 7? What would I do? Well, I bet you can think, instead of adding 11, if I took this 18 and I subtracted 11, I'd get 7. I'd get back to where I started. So that means that subtraction must be the inverse operation or the opposite operation to addition. That's a big idea. Sounds, maybe it's obvious to you, maybe it's not, but it's real important. If I went 7 times 11, I'd get 77. Well, what would I have to do to undo that operation to get back? If I have got 77, how would I get back to 7? Well, you probably could guess that you should divide by 11. 77 divided by 11 gets me back to 7, and that means that division is the inverse operation to multiplication. It's the opposite operation. You can cancel that operation of multiplying by dividing by exactly the same thing. It even works for an operation like squaring. 7 with this little 2, so many people want to go 7 times 2, but that's not what's going on. That little 2 means you're supposed to take 7 and multiply it by itself. Well, that equals 49. Well, what operation would I have to do to undo squaring? Well, there's a word for it. It's called square rooting. So if I've got 49, if I take the square root of 49, I get back to where I started, which was 7. And that means that square rooting is the inverse operation to squaring. And later on, you might imagine if you cube something, multiply it by itself 3 times, the inverse operation is cube rooting. And if you multiply something by itself 10 times, the inverse operation would be taking the 10th root. Well, that's maybe a little hard to think about, but that's inverse operations.